Well, here we go, going to try to build the Morserino-32. I've watched a bunch of YouTube videos to see how others have fared with the project, and now I'm going to try it myself. I'm not a serious technician. I've been in ham radio for 38 years, but I have limited my technical stuff mostly just to assembling cables and connectors. I've not really been into the guts of things and printed circuit boards and all of that. So this will be a new experience for me. But I do have some equipment that I've acquired just to make my life a little bit easier. And this mirrors in many ways the kind of equipment that people were using to build this Morserino-32 themselves. So I'm going to try to not repeat the mistakes that they have made, and they have made some, including experienced technicians have made some mistakes, but it's wonderful to see them make those mistakes, back them out, fix them, and then proceed with the rest of the build. So hopefully I won't make those mistakes at all, mainly because others have made them for me. Had I not watched any of these YouTube videos, I'm absolutely sure I would have made all these same mistakes that they have made. Now, what is a Morserino-32? It's a device that helps teach people how to use Morse code. I already have Morse code proficiency. I passed an exam back in 1984 that had me send and receive 10 words a minute successfully for several minutes. And then a year later, when I wrote my advanced exam in 1985, I had to pass a 15 word per minute Morse code test, which I did successfully. And now when I use Morse code, which is not all the time, but it's frequent enough, I'm in the 18 to 20 word a minute range, which is quite good, but I want to be better, and I want to have a more intuitive ability to hear Morse code and hear it rather than hearing each letter individually in my brain trying to assemble them into words. As you get better at Morse code, so I'm told, you'll start to hear entire words, and it'll be easier to copy the Morse code in your head, and your speed can increase, and your efficiency and proficiency can increase as well. So that's the goal for me, is just to get better at Morse code, something I already know, but the Morserino, with its teaching methods and other features it has, should allow me to do it better. So the Morserino comes from Austria. A gentleman by the name of Willy Krammel invented and makes these things, and my kit arrived after only 7 days in the mail. Willy mailed it outbound from Austria on a Friday, and I got it the following Friday here in Prince Edward Island, Canada. So I'm shocked that it came that quickly, because this was not a special high-cost courier service. This was just in the regular mail, and it came in a week. So the Morserino kit, when it comes in the box, it looks like this. So I'll pull out the various items that it comes with. It has a Lexan type case that will go around it, much like the ones you would see if you've ever assembled a Raspberry Pi and you've got those clear plastic top and bottom pieces for the Raspberry Pi. This is very much the same as that. There's also an antenna here, because the Morserino has an RF module in it that allows it to talk to other Morserinos in the room. And of course you can use the Morserino with a ham radio if you already have your license, and use it on the air too. So there are other little parts here and standoffs and things that make the case all fit around the Morserino itself. And there's the little bag of parts. In this bag are a couple of capacitance reactive keys that you can use to actually key the Morse code. And there's a speaker here, there's a couple of headers, and some other devices, switches, rotary encoders, push button things that all have to go on the printed circuit board. And to me, that's going to be the tricky part, but it's the thing I have the least experience with. And then there's the printed circuit board itself, which is very well packed. Billy's done a tremendous job. I've read a lot of reviews on the Morserino now, and everybody compliments Willy Krammel on the design and the extremely good packaging of all of the components and the very clear instructions. So it's really, really something that's extremely well done. So here's what the printed circuit board looks like. I'll hold it a little closer to the camera, and I hope that it stays in focus. But essentially, there's... Well, okay, I'll start from this side. This is where the speaker goes. There's a header unit called a Heltec module. That will be the biggest challenge for me. That'll have to go on here. And there's other switches and jacks and things that will go on the board as well. The back is pretty nondescript, but that's where a lot of the soldering will be taking place right there. And finally, there's this device here. It's actually it's logic. It's a processor, but it's also a display. There's a little video display that will be right here, and this is called a Heltec module. And the Heltec module, in addition to all of that, it actually has RF capability. So this will allow the Morserino unit to communicate outside of itself using RF spectrum. So that's basically everything, and it's now my job to try to put it all together. When you're going to build a kit, of course, you need to have a soldering iron if you're doing any fusing of tin onto printed circuit boards. So I have a soldering iron that allows me to set the specific temperature that I want. Right now it's set for Celsius, but I'm going to go to Fahrenheit. And I'm going to turn it up to about 700 degrees Fahrenheit is where the recommendation is for the temperature that you should have on your iron. So essentially this is the soldering station. The iron is now heating up. This is to clean the tip of the iron. I have other different tips as well should I need those. I also have a hands-free area so I can clip something to these alligator clips and be able to use both hands to do the soldering. I have two different widths of solder. This will be the main width I'm using in this project because it's nice and thin. For bigger stuff, when I'm doing coaxial cables and so on, I'll use solder like that. For those in the know, this is a 6040 lead-tin combo solder. And because we're working with lead, there are cautions to try to not allow the smoke from the solder to get into your lungs, so people recommend using it in a well-ventilated area. And because it's lead and you're handling it with your fingers, you should wash your hands afterwards and not, of course, put your hands to your eyes and your mouth and so forth. This is a little piece of braid called a desoldering braid. So if I put too much solder on something, this will allow me to put the braid on, heat the solder joint, and this will suck up the solder by, I guess, surface tension, capillary suction, and the solder will then be removed from the place I don't want it to be. I also have another desoldering tool which works on air pressure. Essentially, I can arm it like that. I put the nozzle down to where I want the solder to disappear from. Once I get the solder melted, I hit that. It sucks the solder up out of the way. This is flux. It's a large hypodermic needle filled with a resin material that helps the solder flow onto devices and keeps it from oxidizing while it's still wet. This is an old Morse code key. It's not here for any purpose right now, but that's the thing I'm trying to replace. An old-fashioned Morse code key, which I'm going to get back on the air someday, but it works well. I just have it sitting on my little work table here, I guess. This is another desoldering device. It's a desoldering bulb. You push it to reduce the air pressure inside, and then you withdraw, and then that little nozzle will suck up the solder as well. So I have all kinds of ways to get rid of too much solder if I put too much of it on. There's the parts and the speaker. I also have some little screwdrivers here that may come in handy, but I don't think I'll need those actually. And yeah, that's basically it. Oh yes, I have one other device, and this is a circuit board holder. I'm not going to use it immediately. I may or may not use it during the build, but basically the circuit board can be mounted inside the circuit board holder and then rotated and held in place while I do my thing. And there's the instructions, and I'm essentially ready to go. All right, to give me a little better visibility, I'm going to take off my regular glasses and put on my readers. One thing I do plan to get sometime is one of those magnifying glasses with the light on it that comes in over your desk, and a lot of craft people use those, and I probably will do the same. I'm getting pretty close to finishing this build. I have one more potentiometer to put on in the soldering side of it all, and then I have some physical assembly to do. I have a couple of comments about how it went together, and one of the changes I decided to make to my particular version of the Morserino to put what I believe will be a more compatible battery with it. So, back to the job. Okay, seems to power up okay, and I'll complete the physical assembly of the case according to the instructions. Turn this bad boy on. I don't know how well this is going to do up close. I guess I don't have a macro mode. But essentially I have this tiny little wire connector right here that I have to mount onto the Heltec module that'll carry the RF energy from the Heltec, which is that chip there, to the antenna component, which is right there. That's the antenna piece. Right now I've got the dummy load on it. I'll talk about that in a bit. But yeah, pretty delicate operation. And from what I hear, what I've read, these little connectors are only built to be attached and detached 3 times before they wear out. So I want to get it right, obviously, the first time. Maybe I'll move my little helping hand unit. Ooh, a very satisfying click. I like that. So now I will very gently take that off the handy helper. Nice. Flat onto the socket, apply some pressure. Now mount the top plate with its standoff spacers to the PCB using either 6mm male-female standoffs or 12mm male-female standoffs. Top plate with its standoffs to the PCB. Okay. Now I have determined I'm going to use the longer standoffs because my battery, which is this guy, will not fit under the Heltec module, which is that little chip there. It actually is going to go underneath the printed circuit board, so I need more clearance for that. So I'm going to mount it underneath. So now I need to go and find my longer spacers. 1, 2, 3, 4. There's longer spacers and shorter spacers according to the instructions. So as you can see, there's already spacers here that are on the acrylic now. So my next mission is basically just to bring the acrylic in the way. I was hoping to have this more or less hands-free, but that's not possible, so I have to take it out of the jig, because that's the only way this is going to sit properly. Because that actually dangles outside a little bit. Yeah, I'm going to take the other Morse paddle off too. Now we're talking. Okay, so I'm just going to do one of these at a time. There's one. I'm not going to tighten them up too much because I might want a little bit of play in order to get them better aligned. So there's 2. There's 3. And there's 4. Great. So now it sits. And the little antenna is wired up nicely. It has room for the cable. Nothing is kinked. And now I have a bottom plate that I need to put on as well. Oh, but I'll wait for the instructions. Make sure the display fits into the opening, which it does. the little coil. The RF antenna is poking out through its little opening. Make sure the battery cables and antenna cables run smoothly and aren't obstructing the encoder or the push-to-talk button. That's these two guys. I said push-to-talk, but I meant push button. And careful not to break the copper coil antenna. And don't bend apply pressure or break the flexible connector on the display. Do not exercise any pressure. No pressure, folks. And if the battery will sit on the bottom plate, put the battery there now with double-sided adhesive tape and plug it in. So I've unplugged the battery for the time being. I'm probably going to leave the battery external for now. And maybe this is the part where I'll talk about what I've done a little bit differently. It comes with what they call a Molex connector. And the Molex connector is what you would use to connect it to a 3.7 volt lithium-ion battery. Molex connectors are not that common that I've found on Amazon, for instance. So I decided to not use the wire they sent me, and instead I bought some wire of my own, which I've already installed onto the board here, because it's got a different connector on it, and that connector was easier to mate up with the battery I was more easily able to get on Amazon. So it has no effect on the function whatsoever. And of course, Vili allows for that in the instructions. He says if you want to use a different kind of battery and different kind of pigtail, that's up to you. Go ahead. So I've gone ahead and done that. Just because if I ever have to get another battery down the road and I can't find one with a Molex on it, that's the right amperage and wattage, then I'm stuck. So this way here, using these other kind of connectors, they're called JST connectors, I believe, I was able to find a lot more batteries that would suit my purposes. Normally these batteries go into remote-controlled helicopters and drones and things. So they're quite common, especially in North America. This unit I bought comes from Europe, so maybe the other kind of connector, the Molex, is more common over there. But here, anyway, I'm all set. I have already powered up the unit with this battery using my own cable assembly, and it powers up great. So very encouraged by that. So the next step would be normally to follow their instructions to mount the battery more permanently on the bottom plate, which is this little guy here, and then with double-sided tape, and then the battery basically attaches to this bottom plate and stays in place. Chances are I won't ever have to change the battery very much because it is rechargeable. So theoretically, if I plug it into USB power, as I'm about to do fairly soon, the battery should start taking a charge. There's a circuit in the Morserino that will start to charge the battery. The battery already has almost a full charge in it now, so I have lots of time to play around before I actually start applying power to it. So the next step, in my case, will be just to, for now, affix the bottom plate without the battery attached. I'll continue to use the battery just off to one side, just while I continue to experiment and play with this. So that's what I'm going to do. I still have a lot of room to reach the battery cable, even once the Morserino is put together, so I'm quite comfortable with that arrangement for now. And the moment that I decide I want to make this a little more permanent, more of a marriage, I'm going to take this back off again, and I'll put the battery on it, and then we're in business. These bottom screws that I'm putting on, they attach with a little Allen key, or Allen wrench, some people call it, and they have it looks like a Robertson head, but it's not. It's some kind of hex head or something. But you just have to, it's very much like a screwdriver. You just have to get it lined up right, give her a few turns, and it starts to burrow its way in. If I hold my face just right, which I'm not doing right now. There we go. I'm not going to tighten them super tight. I don't want to crack the plexiglass, so I'm going to be a little gentle with it, as you should be with all these things all the time. I might also disassemble this again later and buff it up a little bit. Get some. I think I've left a few fingerprints on it. I like to get rid of that evidence in case there's any forensic analysis needed later on. There. Perfect. And now I have the fully assembled Morserino. There's one thing I don't have on it just yet, and that is this little antenna. And that's basically the last thing I want to talk about right here. What they now ship this with, and I don't think they used to when they first started making these, they ship this with a little cap, and that's actually called a dummy load. It's just a small resistor in there that's presumably 50 ohms, which the Morserino RF radio frequency component will see as a proper load, so that when you turn the Morserino on, it thinks it has an antenna attached, even though there's no antenna. That way, it won't be trying to put RF energy out this little tiny cable that I just attached and heat up the transistor, that's the amplifier transistor that's in the Morserino that is trying to communicate out to the big world. The other thing I can do, of course, is, if I want to, I can actually attach the antenna for real, and there it is. It's an antenna not unlike the kind you might see on a Wi-Fi router or something. It's rubberized, it's somewhat flexible, and you can bend it, and normally it would sit straight up like that. In my case, my Morserino is not going to have any other low-raw, well, you can find an explanation for that at some point somewhere, not have any other low-raw devices to talk to. And that wire antenna is just, or that rubber antenna is kind of in the way. So I'm going to keep it handy in case I want to use it, because I'm hoping that some of my ham radio buddies will get one of these themselves, and maybe a few of them, and we can all start communicating using these antennas. But for now, I'm just going to use it as a self-study tool, so it doesn't need to talk to anybody. It already has a Wi-Fi connector, that little tiny little spring that I'm just pointing to with my little finger. And that connector will be my connection to my own Wi-Fi here in the house. So I'm getting ready for the next step. The Morserino is now assembled. Rotate to see CW keyer and press black knob quickly. Should start keyer displayed on display. Encoder switch OK. If it doesn't work, resolder the encoder. If persistent, resolder the Heltec socket, pin 37. Jesus. Okay. I need to resolder the encoder, perhaps. All right, I will do that. I got it. I had not done a good solder job on the encoder knob, and I just touched that up a little bit, and now it works. CW is pretty awful. If my CW, my Morse code is really good, I wouldn't need one of these things, right? So, ho! I'm so excited. And now I can put it all back together again, knowing that it works. So I'm going to quickly turn it off before I push my luck too much. I'm going to take it back out of the little jig here. And I won't need the jig anymore, for this project anyway. I'm going to turn it upside down. I'm going to put that bottom plate, maybe I'll give it a little wipe before I do that. Put that bottom plate back on. Turn the soldering iron off. Something I always like to do, because that means the job is done. All right. Well, I'm pretty excited. It makes noise. You gotta like that. It makey the noisy. Smith Allen key. Spin that on. Spin that on. Now we just probably be a little more serious about tightening this, because it's likely going to stay together for a while until I decide to get some double-sided tape to mount that battery underneath in a safe spot and tuck it in. Yeah, this is quite a feeling of accomplishment because I'm not a kit guy. I don't build stuff. I'm not very good at this. I'm not very good at this. I'm just going to kind of shove that in there underneath where it's out of the way, hopefully. Still kind of thick though, isn't it? I might have to think about that. Let's turn it on again. Let's see what's going to happen. Morserino. CW here. Start. Well, thanks for sticking around for that if you were able to. I know it's pushing a half an hour now already. And just a few more minutes though to help explain, maybe to some other beginners like me, some of the problems I had when I was building it. I made three main mistakes. The first mistake was in misinterpreting the instructions. Willy Kreml, who invented this device and drafted the instructions, did a great job. But what I didn't understand at the beginning was the distinction between there is a version 1 and a version 2 of the Morserino, and they are both in these instructions. Version 1's instructions look like this. You turn the page and you've got version 2. To the untrained eye, like mine, they look identical. So what I was doing at first was looking at the circuit board map for version 1, even though I was building version 2. And that led me down to a dead end that was unfortunate, but it's a good learning project for me. What happened was there are two potentiometers that need to be installed in the Morserino-32. They're both blue, but they're not identical. One has a knob on it, something like this. I'll hold it up fairly close, but it has a knob that you can turn back and forth. And it also has a slot in the top with an arrow on it that allows you to turn it, I guess, with a screwdriver or a little trimmer device. The other potentiometer is also blue, but it's basically flat. It doesn't have a knob, and it has more of a screwdriver top on it that you would use to turn it. What I didn't realize when putting this together is I took the potentiometer I thought should go in a certain spot on the circuit board, and I soldered it in place, which is this one with the knob on it. And only later, when I realized there were two different versions in the same set of instructions, did I realize that I put the wrong potentiometer in the wrong spot. So I knew right away I had to get that potentiometer back out of there. So I turned the board over, I heated up my soldering iron, and I did what I could do to gently try to melt the solder away to free up that potentiometer so I could pull it back out and then later on install it in the right place. Well, in the course of doing that, I overheated the bottom of the potentiometer with the soldering iron, and one of the little three legs, the metal legs, came out, and basically now this thing is ruined. So what I had to do was go online, and I went to Mauser actually, and which is an equipment and a component supply place in Texas, very good, and I ordered a replacement potentiometer from Mauser, and it took almost 2 weeks to get to me, but it finally did. So when you've looked at the video, if you notice that some of the things changed or the lighting changed a little bit about halfway through, that's because the build was done in 2 phases over a week apart. And I did manage to wear the same shirt, otherwise other things may have been different, so that's why. But anyway, I had to wait for this other pot to come in. I did finish extracting it that day, and I put the other one in the place where it should go, so everything was awaiting this new pot to arrive so I could install it, which I did. And once I installed it, it went in smoothly in the right place using circuit board version number 2 that I hadn't realized I was on the wrong one. So I guess if I would make a suggestion, it would be if you're shipping, if I'm shipping version 2 of something, I would probably have a separate set of instructions with only things that are relevant to version 2 versus version 1. I'm not trying to be critical. I think the instructions were excellent. All I had to do is read them properly. I didn't do that, so it's really on me. But that's just something I learned. Another thing I did wrong, or I guess not as well as I should have done, and that is my soldering skills. They were rough, to say the least. They improved as my build went on in this one project, but they were rough, especially to start. So some of the things I did early, the earliest pieces that I put on that circuit board, were not very well soldered. And you'll see, well, you've already seen from the video, that my encoder, when I soldered it on, it wasn't completely soldered on properly. One of the joints wasn't really bonding well with the circuit board. So I had to resolder that joint. I checked the other ones, and now it works great. So that was a really big win for me. But one thing I noticed that I really needed a lot was a magnifying device of some kind. This is just a little cheapo one that comes, you can put it in your wallet. It has a magnifying surface on it for general magnification, then it has a little circular one in the corner which is even more intense magnification. I also have a set of those magnifying goggles. And when you're building something like this that has lots of little solder joints that are very close together, you really should have better vision and visibility into what you're working on. Had I had better magnification earlier on, I think I probably would have noticed some of those flaws before I found out the hard way by trying to turn the thing on and it didn't actually work the way it was supposed to. So my 3 mistakes were not reading the instructions well enough to fully understand what page I should be on, being rough with my soldering, and 3, not seeing my soldering job well enough to visually identify that I might have a problem approaching. Once I got those things cured, the thing worked great. I was very impressed with it. I brought it out here so I can actually show you. The thing works great. I've been playing with it a little bit. I don't know how well the camera's going to get this. And if you're into Morserino product generally, you probably have already seen other videos about this. It's a great little toy. So this video is really about my struggles and challenges in building it, not so much how to operate it. You can find way better videos from way better people online about that. But one thing I have done that I think is kind of fun to demonstrate is I've connected it to one of my bencher paddles. This is a Morse code paddle device that makes it much easier to send Morse code rather than those little capacitive paddles that it comes with. It's kind of cool what it came with. It'll actually work right out of the box with these little paddles. There's 2 of them, one for the dits and one for the dashes on Morse code. And there's a place on the Morserino to plug them in. And that's what I was using in the video when I first was testing it to see if I could get any sound out of the thing. And they're cool, they're cute, but they're not really, built to stand up to robust keying. So this is what my bencher paddle is for. I've got a couple of these, one attached to each of my radios behind me. So I've detached one of them and plugged it into the Morserino. And, oh, I gotta push the button for CW keyer. And that's me at 19 words a minute. So, as I said in the video itself, my Morse code's not that bad, but it's not as good as it could be. So hopefully with this device, and using this device in a more social context with some of my ham radio friends to improve all of our ability with Morse code, we'll be much better off, I think. Now, one of the things that I should point out, Morse code used to be a requirement to get your ham license. It isn't anymore, but those of us who have Morse code from the old days when we still needed it to get our license, a lot of us have continued to practice Morse code and to use it in our communications because it is a very robust way of getting signals through and information through to the other side, particularly in poor conditions on the airwaves. So Morse code is still a good skill to have. You don't need to have it anymore to get your license, which is great, but those who do have their license without a Morse code endorsement are encouraged to try to play around with Morse code, and maybe they would like it. And in our local radio club here, we have several hams who don't have Morse code certification, I guess you'd call it, but they want to learn how to do Morse code because they like the sound of it, they like the idea of being able to have that extra skill. So this is the first Morserino in town, the one I built. Hopefully we'll have a few more. But there are other code practice oscillators as well that can be a lot of fun to build and a lot of fun to play with. And as time goes on, I plan to build more things, and maybe I'll put some video on those as well. So thanks very much for your patience. If you were able to stand through that whole 30 minutes of me mumbling and fuffling about, I did speed up a few things. But for the most part, it was probably not the most exciting thing to watch, unless you're building this exact kind of thing. And if you are, hopefully it helped you in some way. I think I'm a better builder now because of what I've gone through with this. I am quite proud of the fact that I maintained my cool and kept patient throughout the whole thing. I'm not particularly a patient person by nature, but I think I learned a little bit about patience in building this thing. So thanks again for watching. Come back from time to time, you might see the odd cool thing here on the channel.